All right, we're looking at proving, we're looking at the proof of reflection of two parallel lines. We did talk about the instruction for case 1. We went through it as a class. And now we're going to share out our answers for case 2, 3, 4, and 5. Okay, Peyton. Let's see what you got. Okay, whole group stand up. I know you're right up front, so it's easier just to sit there. But we're going to be supportive. All right. So, what do we got?
Nothing.
Okay, so you have a picture here, and it looks like you tried to reflect A over line 1. And what do both of these things say? Because they would be the same distance, yes? Okay. And then you reflected it over line 2, had the same distance of Y. Okay, but it's not really finished. All right, thank you. You can go sit down. That was easy and painless. Not as much points as you could have gotten, but something. All right. So this is my second group. We are again sharing. You're sharing case 2. Okay, can you give us a little explanation of what's going on?
Okay, so I reflected the distance between A and A1 is 2x because there's 2 x's here.
So the distance between A and A naught, yeah, is 2x. Good, good.
Yeah, and the difference between A naught
And A naught naught, yeah.
and A primed.
Yeah.
Okay.
No, it's not A, yeah, okay.
Is 2y.
Okay, so what is the distance between line 1 and line 2?
X plus y.
Okay, and what is the distance between A and A naught naught?
2x plus 2y.
Okay, so it's double the distance, which
Yes.
is the whole point of this, is to find that the distance between line 1 and line 2 is half the distance between A and A prime. That was perfect. Thank you very much. Okay, so we need our next group, Melina's group. All 5 of you can come on up. Okay, we're looking at case number 3. All right. So Melina.
This isn't mine, so I get confused on this one. I
Okay,
didn't really
so
understand
give me the best you got, girl.
Well, it says you gotta reflect from A over line 1, which is
Okay,
on this side.
so A is way over here, so we've got to reflect all the way to line 1. Stop talking. Okay, go ahead.
That's really the farthest I got on my paper without
Okay.
getting confused.
And so we reflected this from to A, and then that's A naught, and then what happened after that? We reflected over line 1, and then you should have reflected over line 2. So this isn't quite what I'm looking for. All right, thank you guys. Please go sit down. My next group, Lindsay, Manaya, Rena, sorry, Brendan. Okay, so we are looking at, we can just zoom out a little bit. All right, Lindsay, you want to explain to me what's going on?
Just like I reflected the
That whole distance right there?
this whole distance.
Okay.
And I took this and I reflected it over here.
Okay. Can you tell us what is the distance between line 1 and line 2?
X.
Okay. And what is the distance between A and A naught?
X or 2x.
2x. So it's double the distance, which was the whole point. So you see she labeled this X, she labeled this X, so she went over, and then she went back over. Some of you have this as X and this is Y right here, and then you went over X plus Y, and then you went all the way over here and you got 2X plus 2Y, which is equally as right. Okay, thank you guys. All right, Ashlyn, Matthew, Jonathan, can you all come up here, please? Okay, we are looking at case 4. Okay. All right, Ashlyn, what did we find? If we found that this if we reflect this over line 1, does it move?
No.
No, it stays in the same place, right? But then we have to have this whole distance reflected over here. These should be equal on both sides. Okay, thank you guys. You can go sit down, that's all. All right, Levon. Brandon, come on, you gotta get up with them. Let's go, guys. Okay, you're showing us.
This way?
No, you're showing us 4 and 5. Okay. You're showing us number. This is 4. Okay, there's roof. Okay, so, all right, Levon. I see that you have A here. If we reflect that over line 1, it should stay in the same spot. And then I do not see it reflected over line 2. Okay, thank you guys.
On the other side.
Yeah, it shouldn't be though. All right, thank you. You can go sit down. Let me show you the way that this is done. All right, so line 1 is right here. If we reflect A over line 1, it stays in the same spot. Then the distance between line 1 and line 2 we can say is x. If we reflect this whole distance over here, we again get x. So the distance between line 1 and line 2, you see it? Equals x, right? And the distance between A and A not is 2x, right? It's double the distance. Yes, you did. Okay, and my last group.
Wait, can you?
Yes, I can leave it up there for 1 second. Okay? All right, my last group. Come on up. All right, Lindsay. Okay. So we started with A here, right? And we reflected it all the way over line 1. And then we reflected that back over line 2. So what's the distance between line 1 and line 2? And what's the distance between A and A not? Okay, thank you guys. All right, so for this one, we've got A. Can we see it? Okay, we've got A is on line 2. We're going to draw a perpendicular line to these parallel lines. We're going to say if we take A and reflect it over line 1, we get A naught over here. We're going to say this is x distance. All right? If we take this whole thing and reflect it over line 2 in my nice perpendicular line, we get 2x. So the difference between line 1 and line, can you guys see it? Better? 2 equals x. And the distance between A to A not equals 2x. Okay. On your quiz on Friday, you will have 2 problems like this, and then you'll have 2 problems like your next packet. Okay, if you do not have the next packet, you can go ahead and raise your hands.